Welcome. We are working today on factoring trinomials where there is a coefficient other than 1 next to the x squared term. And this coefficient makes us have to look at the problem a little differently than we have been in the past. So in the past, one of the first things that we did was we set up two sets of parentheses, and we're going to do that again this time. The big difference is we need to have a pair of numbers that multiply to give us our first term coefficient that go before the variable that we normally put in there. So normally we just put an x and an x. Now we have to put a number, then the x and x. We need to include our signs, which are plus and plus in this case. And we also need a pair of numbers to give us 15 that go at the end of each. Now, the double underline goes at the end of each parenthesis. The single underline goes at the beginning of each parenthesis. I can pick pairs to give me 2, and there's only really one pair, 1 and 2. I can also pick pairs for 15, like 1 and 15, or 3 and 5. Now these pairs of numbers I could just throw in there and hope for the best. I have other ways you could approach that, but let's try that. Let's just throw it in. Say 1, 2, probably 3 and 5. Let's just throw that in there. And see what it gets us. Well, we know if we use a pair in red, that's going to multiply to give us 2x squared. And we know that as long as we put one of the pairs from green and I multiply those together, they give me the last term of 15. Well, how do I know what I get for the middle term? Well, if I distribute this outside pair and this inside pair, the results of that are going to be your middle term. Now you're multiplying here. 3 times 2 is 6x. 1x times 5 is 5x. And when I add those together, the result is 11x. Now what did I want? I wanted 13x. That's not what I wanted. So I'm going to toss that to the side, and what I really need to do is I can choose to keep the pair of 3 and 5 for the 15. I could choose to replace it with the 1 and 15. I have a lot of options here. And probably the best thing I should start with, though, is I should swap a pair around to see if that will make the difference. Here's what I mean. I'm going to take the 3 and the 5 and swap places. That still gives me the 15 on the end. The very worst thing you can do is to swap a single underline with a double underline. That never will give you a good result. Only swap single with single or double with double. Never mix the two. So I'm going to swap the 3 and the 5 and see what that does. So 5 times 2x is 10x, 1x times 3 is 3x, and when I add those together, sure enough, I get my 13x I was hoping for. And there is your final answer. By the way, all of this stuff, all of that stuff down there, that has nothing to do with the problem. And by the way, I don't know if I mentioned it, this is a method I like to call smiley face. You've got your 2 eyes, your nose, and your mouth. And it's just a fun way to remember what we're doing here. But all that smiley face stuff down here, that has nothing to do with the final answer. The final answer is really this. X plus 5, 2x plus 3. That's our real final answer. All right, now that we've done that one, let's try and look at another example. Again, two sets of parentheses. Your variables go in the beginning, but with a little gap there, so we can do our pair of numbers to give us 8, single underline. Our signs are a plus and a minus when we look at our sign chart, because they have to multiply to a negative, so it has to be a plus and a minus. And then a pair of numbers to give us 21 that are here and here. So let's write options. Here we go. 8, 1 and 8, 2 and 4. 21, 1 and 21, 3 and 7. Now when you get down to this and you start looking at it, I have a lot of different ways I could put this in here, and you can do a lot of writing and rewriting. And some of you, that's going to be your most comfortable way to do this. But as we get to more and more options in our list, sometimes you're going to want to use what I like to call a pointing method. And that's where you pick one from the red and one from the green, and you point at them to say to yourself, if you can do this in your head, you say to yourself, all right, what do they multiply to? Now, remember, when you have different signs, not the same signs, but different signs here, then you're really adding the two, and adding a positive and negative really is like subtracting, right? So when I get my two values from the multiplication that I'm going to show you, you're really subtracting them to get 22. So let's try this. 4 and 3. Let's say I picked those first. And the other thing I want to mention is when you are multiplying, or picking values or pairs, let me say it that way, when you're picking pairs, you really want pairs that start close together, like 3 and 7, 4 and 2. They're much closer together than 1 and 8 or 1 and 21. Those tend to be the answer. It doesn't mean it's always the answer, but they tend to be the answer. Let's see what that happened, how that works. 4 times 3, 12. 2 times 7, 14. 12 and 14. Do those differ by 22? The answer is no. So that's not the pair I want, so I'm going to try swapping it around. So we started with 4 and 3. Let's do 4 and 7, 2 and 6. 4 times 7, 20, 28. 2 times 6, 2 times 3 is 6. Do those differ by 22? They do. So 4 connects with 7, 3 connected with the 2. That's how we wanted them connected. Now, here's the tricky part. When you come back over here, you've just thought about the connections, but you really want the 2 and the 4 to be the ones that go in the red single underline spot. Now let me see what I can do here. I'm going to write it out like this. 2, 4. We know that the connection for 2, that 2 is supposed to be connected to 3. So I'm going to fill in 3 here, and that 4 is supposed to connect to 7. So I'm going to put 7 here. How is that red? Frustrating. All right, so let's try the multiplication part. 7 times 4x is 28x. 2x times negative 3 is negative 6x. Now when I combine them, they give me a positive y. When I combine them, they give me a positive 22x. What did I want? I wanted a negative 22x. Well, I didn't get what I wanted. I got the right number, wrong sign. If you have different signs and you get the right number, wrong sign, swap. Come on. Board is not behaving today. Swap the signs. Right number, wrong sign, swap the signs. Because what you're going to get now, negative 28x, positive 6x is going to give me a negative 22x. Now I have the one I want. So my final answer here, 2x minus 7, 4x plus 3. All right, there's our final answer. Why don't you guys give this one a try, and then after you've tried it, unpause it. So pause it first, and then unpause it and see how it's done, and see if you get the right answer. Go ahead. All right, so 2 sets of parentheses, not like that though. 2 sets of parentheses. X at the beginning with a space. We're going to fill that with 16, and then we're going to put the end with 6. We need our signs of a plus and a minus. And let's see. I don't know the answer to this one. I have to figure it out. 16. 1 and 16, 2, 8, 4, 4. 6. 1 and 6, 2 and 3. All right. We want our smiling face here. 2 eyes, a nose, and a mouth. Here we go. I want 29. So they have to differ by 29. I don't think 4 and 4 is going to be a good option for me. Because 8, 12, that's not going to differ by 29. All right. So I could even try that up here. 4 and 24 still doesn't differ by 29. So I'm throwing 4 and 4 out. Let's try 2 and 8. 4, 24. Well, that differs by 20, not 29. 16 and 6 only differ by 10. So I'm going to toss, well, I can try it up here. 2 and 48. Nope, that doesn't differ by 29. 8, 12 still doesn't differ. So 2 and 8 are gone. So I only have 1 and 16 as an option. And we said most of the time they were close together. But in this case, they are not. All right, 2 and 48. Nope. 32 and 3. Those differ by 29. And that, 29. And that is just what I wanted. So we had connected the 16 and the 2, the 1 with the 3. So I'm going to go ahead up here and put in the 1 and 16 for x. I think I want the 1 here and 16 here. And then I want the 2 connected with the 16 and the 3 with the 1. This gives me 32x and negative 3x. Sure enough, that gives me a positive 29x. And there you have it. Hopefully you got it right. All right, let's take a look at our next example. All right, so in this one thing that throws students off a lot is when they see x all by itself. And they go, all right, what's that? I'm confused. Well, if you see x by itself, that's understood to be a 1x there. So we're looking for a difference of 1. So I'm going to put my pairs. I know 3 is the only option, 3 and 1 is the only option for 3. So I'm going to write that right in, 3x, 1x. I don't know which sign should go where, but I'll just go ahead and throw in a plus and a minus. And I need a pair of numbers to give me 14 that go on the end. Remember, we used 3 and 1 to get 3. Smiley face. And 14, 1 and 14, 2 and 7. Let's just go ahead and throw 2 and 7 in there, see how we do. 2, 7. Well, that's going to be 3x and negative 21. Yeah, that's not even close. They don't differ by 1. So let's back that up. And let's try swapping the two. That's going to give me 7x and negative 6x. And sure enough, that happens to be 1x, and that's exactly what I wanted. So my answer is 3x plus 7, 1x minus 2. You can do the pointing over on the side. I just didn't do that in this case. Some students are going to want to just plug them in and try until they get the right pair. And that is not a problem. All right, is this our last example? Yes. This is our last example for today. There is one thing I will mention, and that is when you get a large number like 77, you might want to start with slightly bigger numbers instead of the closest ones together, but not always. Let's see how this works out. Now in this case, a pair to give me 18 and a pair to give me 20. I know my signs have to be minus and minus in this case, so we are adding the results of our smiley face, not subtracting those two values because the signs are the same, right? So let's do our smiley face here, kind of a smirk there. Let's see, 18, 1 and 18, 2 and 9, 3 and 6. Let's do 20, 1 and 20, 2 and 10, 4 and 5. Now that pointing method has to add up to 77. 24 and 15 aren't even close. 30 and 12 still not close. So let's try a different pair. Let's see, 6 and 60, that's closer, but it's still not going to be big enough, and if I swap them, I'm not even going to come close. Let's try 4 and 5, 2 and 9. 8 and 45, not enough, and if I swap it, it's not even close. All right, 90 and 4, well that's close because it's bigger than 77. It's not going to work, so 18 and 20 certainly don't. Let's swap it around and try something else. How about 120? Nope, that's too big. So how about 6 and 60? Nope. All right. 9 and 60? No. Wow, a lot of choices here, and I haven't come up with the right pair yet. 4 times 18. Let's see, 40, 50, 60, 72. 4 and 18 is 72. 1 and 5 is 5. That does make 77. Finally found the right pair. That was difficult to find. So 1 and 18, because of the signs, it doesn't matter for the first pair where I put them, as long as they're in the first underlined spot. Now I have to connect the 4 with the 18 and the 1 and the 5. So again, 4 times 18, 40, and 32 is 72, negative 72x. 1x times negative 5 is negative 5x. That does give me negative 77x. And I've got my right signs. And my right answer for the middle term. It's the hardest type of factoring that I can think of that we'll be covering. So it is a little bit tricky, and it takes some time and patience. See what you can do with this, and we'll continue this tomorrow. Have a great day.